Hi, my name's Rob Fletcher from Netflix. I'm going to be talking today about the adoption of Kotlin within my team at Netflix, which is developer delivery engineering, rather, and within the larger engineering tools organization, which I'm a part of. So let's start off, I guess, by talking a little bit about programming languages generally at Netflix. One of the things I think is worth talking about here is that Netflix as a company is pretty different to a lot of other companies. I often get asked, what is the Netflix development stack? What's the set in stone set of libraries and tools that you use? And the answer is there isn't one. Netflix's culture, if any of you have seen the culture deck, is one of freedom and responsibility. You can do anything you like as long as you own it at the end of the day. If it all blows up in everyone's face, then that's on you. You can summarize that as you build it, you own it. So there's no ivory tower function specifying a kind of development stack, telling us what languages we can use, what tools and libraries and anything else we can use. Teams are free to adopt whatever technologies make sense. So this leads to a pretty interesting plethora of languages within Netflix. I actually managed to gather some data using some internal tooling we have that scrapes our stash repositories, which includes mirrors of everything we have host on GitHub for the open source stuff. And this is what the breakdown looks like as a word cloud. So you can see we have a heck of a lot of JavaScript and Java, very significant amount of Python, quite a lot of Groovy. But if you look right in the top middle there is a growing little piece of Kotlin. So there are several teams using it. I believe there are 86 projects that have some amount of Kotlin. Did we just lose video? No, there we go. Thank you. There are 86 projects within Netflix that use some amount of Kotlin. I don't know what all of those are. One of the things I really should have found out before today was whether the Android app for Netflix is built in Kotlin, and I have to shamefacedly admit that I actually have no idea. But we'll start by talking about some of the things that engineering tools as an organization have built. Is anyone here familiar with Nebula, the Netflix build language, which is kind of a set of extensions for Gradle? Yeah, 3 guys in the front there should know because they wrote most of it. But, so it's a set of, I believe, at the last count, there were 43 Gradle plugins and extensions that build on top of your stock Gradle and apply a lot of conventions to existing plugins or to the core Gradle functionality to encourage you to build things in the Netflix way. So we've got things like the dependency lock plugin, which kind of locks down very specific versions of dependencies to avoid conflicts. We've got resolution rules. We have things for deploying and versioning and managing releases within Nebula. So obviously, being as these were on top of Gradle, and this project's been running for quite some time, the majority of that was written in Groovy, with some amount of code written in Java, mostly in places where performance was a real consideration, particularly where things that may rely on Groovy's dynamic compilation and method missing support was causing performance issues in certain places. But that's similar to Gradle itself internally. A lot of it's actually written in Java. A lot of those things within Nebula are now being converted to Kotlin. I think the resolution rules plugin is completely converted already to Kotlin. Some of the core Nebula plugin, the base Nebula plugin, is being converted. And the team's kind of taking an approach of converting things as they touch them, as modifications are made, rather than trying to do an exercise of rewriting things. In some cases, it's difficult where the dynamic nature of Groovy is something that the plugin is relying on, but yeah, mostly it's gradually converting to Kotlin. It's still being tested in Spock, and testing is a subject I'm going to come back to towards the end of the presentation, because I think Kotlin is, while it's very mature as a production language, I think there's still some work to be done in the testing arena, and we're pretty heavily invested in Spock at Netflix generally, and me in particular, being as I wrote the book about it for O'Reilly not too long ago, so I have a lot of affection for Spock still, and we still use it quite heavily, but we'll talk more about testing in a little while. All the build files, interestingly enough, for Nebula and for all the other projects, as far as I'm aware, that I'm going to be talking about, are still written in Groovy. We're not yet adopting the .kts format. I've tried to use it a few times and got stuck several times. I think it's going to be great when they get it working, but it's not maybe quite there yet. And obviously, the fact that Kotlin is now being pushed by Gradle themselves as the standard way to write plugins has meant that adoption was encouraged within the engineering tools org at Netflix that are building Nebula. Some other really interesting projects that engineering tools works on are Astrid and Niagara. These are internal tools. They're not open source. They're very heavily dependent on the Netflix platform, I think. But they're very interesting and very powerful tools. So Astrid was initially started writing in Groovy, but has subsequently been converted to Kotlin. So that entire application is written in Kotlin. It's a set of microservices. Some of the library code, I believe, is in Java. And what Astrid does is it indexes our cloud infrastructure. So it's out there looking at the thousands and thousands of server groups that Netflix has deployed in AWS, thousands, hundreds of thousands probably of instances, and scraping those for metadata. So we can figure out, using Astrid, which, given a particular version of a library, which applications out in our cloud, which instances are actually using that. So this is really useful, for example, if our security team flags a vulnerability in a particular version of some jar file that's open source, we can fairly quickly figure out all of the places that's being used in the entire Netflix cloud deployment and come up with some kind of plan for mitigating that vulnerability. So Astrid's a really interesting and wide-ranging application. Niagara is perhaps, I remember thinking the idea behind Niagara was a really great one some years ago before I'd ever heard of somebody being crazy enough to actually try and build it. What Niagara does is, given a library, it will attempt to upgrade the dependencies of that library to the latest versions, and then find everything downstream within Netflix that uses that library and everything that transitively uses the things that use that library, and go and run all of their builds in Docker containers in the cloud to see what breaks. And that way we can discover, when Guava does one of their classic breaking changes between major versions, or minor versions rather, we can find where those problems are going to be before anyone goes and deploys anything that maybe could be a little better tested, and those things may not get caught until runtime. We can maybe detect that a little early. So this is an amazing piece of technology, 100% written in Kotlin, that goes out there and builds any arbitrary projects from within our entire source code set of source code repositories, using modified versions of the sort of source dependencies way upstream. Another project that I couldn't find a cool picture to describe is what we call GoMan, which is just really a set of online man pages. So this again is scraping source code repositories, looking for documentation, and presenting it, indexing it using Elasticsearch, and presenting it in a searchable format on our internal VPN, on our internal network. Again, all written in Kotlin. So engineering tools is quite heavily invested in Kotlin. I believe I'm right in saying that I kind of got super interested in Kotlin maybe a couple of years ago and talked about it excitedly to Danny Thomas and John Schneider, who were in Eng Tools at the time. John since left us to join Pivotal, working on Spring. And they were really impressed with this new language, and they just ran off and started building things in it. And I wasn't exactly in the same team as them. I'm on the Spinnaker team, delivery engineering. And it took me until about 6 months ago before I could catch up and start writing Kotlin in anger myself. But it's been a real pleasure to be able to do that. So I want to talk a little bit about Spinnaker now. So anyone heard of Spinnaker, just out of interest? One or two people. So this is Netflix's open source continuous delivery platform. Built in primarily by Netflix, but with a lot of investment and contribution from GitHub. Sorry, not GitHub, Google. Everything starts with G. Google, among others. So what Spinnaker does is, it's a kind of cloud control plane, effectively. It allows us to control our deployments, visualize and control our deployments across multiple AWS accounts, and across multiple AWS regions, but not just AWS as well. This was designed from the ground up to be multi-cloud, and it's works with Google Compute Engine, Azure, OpenStack, Oracle Bare Metal Cloud, and various other providers, including Titus, which is Netflix's internal container cloud, and Kubernetes. So you can have, at Netflix we purely use AWS, but there are other teams out there in open source land who are using, or in the community rather, who are using multiple clouds at once. Waze, for example, is deploying stuff to GCE and AWS simultaneously, and you can visualize it all in the same control plane on the same page. So we have a kind of container infrastructure management side of it, and we also have these deployment pipelines that enable you to do things like building and testing your code, running canaries, which are, if anyone doesn't know what they are, they're kind of, the idea is you stand up a new and an old version of your platform, you direct a certain amount of real-life traffic to those and compare the telemetry between the two to see if things are looking good. That's a pretty standard way of getting things done at Netflix. It's kind of testing in production, but the good kind of testing in production. And we can run those using Spinnaker pipelines. If anyone was in Cedric's talk a little while ago, he talked about, what was it, topological sorting of tasks that are dependent on one another, and this really reminded me of how we construct pipelines within Spinnaker. The stages in a pipeline, whether they're deployment, baking, running canaries, running scripts, running Jenkins jobs, all kinds of different things you can do. They have dependencies and are graphed together in a very, very similar way to what Netflix was, to what Cedric was talking about. And Spinnaker is used by almost all of Netflix. There are a few teams. Again, coming back to this whole culture we have of freedom and responsibility, nobody in Netflix is going to teams with a stick saying, Spinnaker is what Netflix uses to deploy stuff. You have to use it. If they don't want to use it, they don't have to. So we have to build a better carrot to encourage them to actually use it. We don't have it. We're not given a stick to tell people to use it. So that's a kind of high-level overview. I won't bore you too long with the ugly architecture slide, but I'll quickly run through. We have a suite of microservices that make up Spinnaker. We have, at the core of it is one called Orca, which is the one I've primarily worked on in my time at Netflix, which has been 3 years now. Orca is the orchestration engine that is responsible for taking pipelines, stages, tasks, coordinating them, figuring out, based on this one completing, which ones can now run, monitoring them as they proceed, updating statuses, and all the kind of managing all of the calls out to other services within Spinnaker itself. Spinnaker, all of these microservices are Spring Boot. Mostly they were written in Groovy to start with. Partly that's a historical thing. Spinnaker followed up a previous Netflix application called Asgard, which was used for cloud management. It was AWS only, and it was like single region at a time. You had to go to a different page to look at different region resources. So we wanted to build something more coherent there, but Asgard was a Grails app. Grails being the kind of Groovy on Rails, effectively. People hate it when it's called that, but that's kind of what it is. Platform that we built Asgard in. So a lot of the hiring for the Spinnaker team when we started to ramp that up came from the Groovy and Grails community, including me. So at the time when we started working on Spinnaker, Java 8 wasn't available, and I don't think any of us had much of an appetite for writing Java 7 production code. So we did adopt Groovy, even though we were just using Spring Boot and not Grails. Over the time, we've kind of grown a little, not dissatisfied exactly, but we're starting to finding ourselves moving away from Groovy a little bit. And earlier this summer, we decided to go for an extensive rewrite of the core parts of Orca, which is the orchestration engine. And as part of that, we decided to use Kotlin to do that. So most of the guts of Orca now, the really interesting parts, the core of it, are now completely written in Kotlin. So I'm going to talk a little bit about why we made that decision and how we came up, why we made the decision to rewrite it to start with, and then why we chose Kotlin to do it. So Orca was the first thing I wrote when I joined Netflix 3 years ago, and it was kind of prototype code that lived on past the point it really should have lived on. It had a number of operational problems that made it a not very Netflix-like service. It was stateful, so we found that if we lost instances, if we had failures, we would lose work. If we couldn't just do what we call a red-black deployment within Netflix, which means we stand up a new server group running new versions of code and just disable the old one and switch it off, we would actually have to drain work because we couldn't migrate the work to the new instances as it was running. Once a pipeline was set off and running, it had to run on that same instance it started on. And that's fine for something that's resizing a server group and takes a couple of minutes, but it's not so fine for somebody's canary that takes 3 days to run. The chance of having some kind of failure during that time, taking the work out, was non-trivial, and it happened a couple of times. Worse could be that we could deploy something that would break it and then lose people's work that was running for a very long time. It was mostly built in using Spring Batch. Just that was something quick to get up and running with. It's not really what it was designed for, though, and it was a bit of a case of bashing a square peg into a round hole in a lot of cases there. Spring Batch is fine for what it does, but building a like distributed workflow system with it is not really what it's for, I guess. There were some really bad abstractions in the code. We've had the Spring Batch concepts leaking through to various places where they shouldn't be. The system was designed to be extensible, so developers in other teams could write stages and tasks that would run on Spinnaker. But there was some bad abstraction there that meant that Spring Batch concepts were leaking through there. And it was incredibly difficult to debug, extend, or modify. We knew about these issues for a long time, but we were so busy bashing out new functionality for other areas of Spinnaker that we never really, we knew it was bad, but it never really caused us major problems. Until earlier this year, we started to really experience a large ramp up in traffic, so we decided to, and then the problems started to become evident, and we decided to embark on a rewrite. And it was something I'd been wanting to do for 2.5 years at that point, because I knew it was terrible when I was writing it, and I was really glad to be able to replace it with something better. So obviously, since we'd started Spinnaker, Java 8 had come along, Kotlin had come along, we'd experimented some with Scala within our team. So the question came up, well, do we have to write this in Groovy? We're not, besides Spock, which I have a lot of time for, really enjoy it, I'm not enormously keen on writing production code in Groovy anymore. So we decided we should kind of evaluate the different languages we might want to use to do this. So let's run through some of the pros and cons. So we could obviously just stick with Groovy because our team knows it well. It's a pragmatic language. It's pretty straightforward. It cuts down on the horrible boilerplate you have to write when writing Java code. We found ourselves using the compile static annotation in Groovy quite a lot, which changes Groovy's behavior a little bit. And it's, funnily enough, when compile static was first announced for Groovy, I thought, this is crazy. The whole point of Groovy is that you have metaprogramming, and why would you want to statically compile it? And as I came to use it, I found I actually liked working that way. I liked the stronger typing. I liked the static compilation. But Groovy's adoption of it was kind of not an afterthought exactly, but it was kind of added on later, and I was never entirely satisfied that it worked as well as I wanted it to. For example, we were using RxJava in a number of places, and the type inference just kind of failed when you were using statically compiled Groovy, and we would end up solving problems by switching the static compilation off and just letting it compile dynamically, which, it was always I'd be reviewing somebody's pull request on GitHub and see that they've removed the compile static annotation from some class. It's like, why couldn't you just spend another 10 minutes getting it working? But, so we'd get into those kind of discussions, and, then you find that if you've got overloaded methods, they dispatch differently in statically and dynamically compiled Groovy, which can be really confusing. And there are annoying bugs like the interpolated strings is a different class from a regular string. If you accidentally put one into a map as a key, you can then find you can't retrieve the data with a regular string because the two things don't hash the same way. It's the limitations of the typing of closures become quite evident if you want to do anything with a really rich DSL and have the IDE help you. Closures can define a return type, but they can't really define a delegate or their parameters in the same way that you can in Kotlin. You can do it with some annotations, but it's kind of this really obscure, clunky, very verbose syntax to do so. So we weren't super keen on Groovy. The other option is we could just let's go with Java 8. Java 8 has lambdas, right? Lambdas are pretty awesome. But you think, okay, I can do some amazing things with lambdas, but then you're like, oh man, I have to remember to put semicolons on the end of everything, and I still have to write getters and setters, and I don't have proper value types, and I'm writing all this boilerplate code. I don't have interpolated strings. Type inference works in lambdas, but it doesn't work anywhere else. Why is that, I wonder? You don't have immutable collections unless you bring Guava in or something else. You don't have collection literals, so like constructing a map that's going to be a constant is horrendous in Java. And one thing that always bugged me was, you write this nice bit of kind of pseudo-functional code using lambdas, and then you find that something inside one of the lambdas needs to throw a checked exception, and none of the lambda signatures will let you do that, or none of the SAM types that the lambdas are being coerced to will let you do that. The streams API is kind of a fudge. It's kind of functional, but it's, why isn't a list a stream already? Why do I have to turn it into one and then convert the result back into a list again? It's just more boilerplate again. So we end up fixing a lot of these problems by using hundreds of libraries. We brought Lombok in to give us value types, which is okay up to a point, but it's kind of a monkey patch, right? And it has a val keyword that isn't super reliable in IntelliJ. So, lambdas are lovely, but we didn't really want to be writing too much Java 8. We looked at Scala. One of the things we were really trying to achieve with the rewrite of Orca was something that had better runtime and operational characteristics. So we wanted something that would actually naturally let work flow across a cluster. That it wouldn't pin work to a single Orca instance, that if we lost it, there's a big problem. We wanted to let the work distribute itself naturally. So Arca came up. Arca can cluster. It's a kind of designed for those kind of distributed systems. So we did have a bit of a dive into Scala, and we wrote 2 microservices in Scala using Arca. And what we found is the learning curve was kind of steep with Scala. It's a very powerful, really fascinating, interesting language, but there's a heck of a lot of it. And it has some really great features. The pattern matching is first class. Kotlin has some pattern matching, but it's nothing like as powerful as Scala's. One day, maybe it will be. Partially applied functions are great. But, we had an existing code base as well, written mostly in Groovy with quite a bit of Java as well. And one of the things we found with Scala is it's not as compatible with Java as Groovy is, and certainly not as compatible as Kotlin is. It's not super easy to interoperate between the two languages. For example, Scala has its own collections library built into it. So if you want to convert... I lost picture again. Is that me? Am I doing something? Am I not doing something? There we go. So if you want to convert if you have a library that's returning Java lists or Java maps, and you want to use them in Scala, you have these conversion functions, and you kind of worry about the runtime cost of that. If you've ever tried to use from Java a Scala API that uses partially applied functions, that's a world of pain right there. That's particularly interesting. And I feel like, I don't want to rag on Scala. I like it as a language, but sometimes it kind of sacrifices clarity. Like implicits are just a way to confuse yourself. The kind of anything goes approach to operator overloading can result in this really symbol-heavy syntax that's not that easy to read sometimes. The generic syntax I never got to grips with and still don't understand. I'm just not really clever enough for Scala, unfortunately. and realistically, the tooling wasn't great in IntelliJ. It was kind of okay. Compilation time is somewhat of an issue, and it's kind of alarming to see how that scales as your service gets a little bit bigger. So although we found some things we really, really liked about Scala, we decided not to go with it. We also found, interestingly enough, that although Orca has a clustering library, clustering extension rather, we found it kind of difficult to get it working and integrated with Netflix's service discovery, which we kind of get for free on our Amazon machine images. It was kind of difficult to integrate the two things. So that was slightly more painful than we anticipated. So we came around to Kotlin. And it's, Kotlin seems to have everything that I like about Groovy and Java 8 and Lombok and Scala, or most of the things I like about Scala, in one language. It's one streamlined package. It's really small. It's a very small standard library. It doesn't reinvent the wheel with collections, APIs, and things like that. It just decorates the Java one, so you're not doing these expensive or potentially expensive conversions at runtime. It enables you to reuse Java's libraries. You spend a decade of your career learning all these hundreds of libraries that are out there, and to be able to leverage that knowledge is a powerful thing. You can get things done pretty quickly, and most of them are just as easy to use from Kotlin as they are from Java. I found that people on a team could be effective in Kotlin within a day, and like writing really good idiomatic Kotlin within a week or so. It's not a difficult language to pick up if you know Java and you're familiar with some of the concepts of functional programming and some of the more modern language features that it's aiming for. And one of the downside is, it's a new language. Is anyone going to use this? Are we chasing after something that in 2 years' time is going to be dead, and we won't be able to hire anyone to touch it? Like happens with some of the JavaScript frameworks, where you adopt some fancy new framework, and 2 years later, none of the guys that you want to hire wouldn't want to ever touch this framework again. But it seems like that's not going to be the case with Kotlin. And one of the examples I think that's a really good example of how elegantly Kotlin blends pragmatism with modern language features is its approach to Null. So we've all heard of the billion-dollar mistake. And the approaches these languages take to that are kind of telling. So Java 8 introduces optional and encourages you to use it except where you shouldn't. And there was some really interesting debates that appeared on the internet about where you should and shouldn't you be using optional, and where you should and shouldn't be using null. Don't use, I can't remember whether you should use optional at the edges of your API and not internally, or vice versa, but there were extensive arguments about that back and forth for a while. Groovy gives you some ways of handling null, so it gives you that kind of null-safe reference operator, and it gives you this concept of groovy truth in which anything can coerce to a Boolean, including null always coercing to false, or non-null by default coercing to true. So you can kind of test for null slightly more easily and handle it a bit better. But again, the compiler is not going to give you any kind of hint about whether something may or may not be null. Scala, I got told off for saying this once, but Scala kind of, I'm going to say it again anyway, Scala kind of pretends that null doesn't exist and you should just use option, and everyone's going to use option and everything will be fine. But of course, there's no runtime, there's no protection from bad code using null when it shouldn't. There's also no protection from Java libraries that have used null for years and are going to continue to return it. And I think that the wonderful thing that Kotlin does is just do this best of breed approach where nullable things are option types. You don't need a special wrapper for it. If you put a question mark on the end of the type, that is the same as in Java 8 saying optional string, optional object, whatever it is. But it's backwards compatible. So you've got this best of both worlds approach. It's just so clever, so pragmatic, so elegant. Doesn't shut you off from all these libraries that are out there and are continuing to use null and always will. Okay, there's some fudging with platform types, and that gets a little better when you when you use annotations to define things that can and cannot be null. Although even that has limitations. But Kotlin is the only language that kind of approaches this in a way that gives you a robust type system and addresses the backwards compatibility concerns and the fact that null is not going to go away on the JVM, like it or not. So I think that's a great example of why Kotlin is a really interesting choice. So over the course of this summer, I spent a lot of time rewriting the core of Orca in Kotlin. We came up with this, what I think is quite a neat queuing system. So we have a queue that's Redis backed, 100% written in Kotlin. It's now handling like 7 million messages a day. And those messages are atomic pieces of work saying, either this stage is started or finished, or you should go run this task now, or this execution is completed, this pipeline is finished. So they're kind of state changes and instructions to run atomic tasks. So there'll be thousands of those for any given pipeline, I guess. And the work naturally just flows across the Orca cluster. We can deploy Orca, just nuke the old instances. We can run Chaos Monkey against Orca and just have instances taken out randomly. And the work just doesn't get lost. It just carries on. And because we're synchronizing on a single Redis instance, we kind of have a cheaty way of getting close to guaranteed once delivery, which is supposedly impossible. But because we're synchronizing on Redis, that's somewhat possible. We do some interesting stuff to guarantee that. And we have messages retrying. So if a microservice goes away, or we have some kind of network connectivity issue or security group that goes missing or something, it'll keep retrying for a certain amount of time. And we deploy Orca now under load with no downtime. When we have our encoding guys running thousands and thousands of individual instances encoding TV shows overnight and things like that, we can deploy Orca while that's happening, and it's without a blip. So when I was writing this, I didn't want to push Kotlin. I started experimenting with writing this queuing idea in Kotlin, and eventually it grew into the core of what's now the center of Orca. I didn't want to push it. I didn't want to be the guy that's like, I'm so enthusiastic about this new language. You should all go and use it, because maybe I'm just being a bit blinkered. So I made it very clear to the team and to the people at Google that we partner with that I'm happy to rewrite this stuff in Java 8. I think it's perfectly possible to rewrite in Java 8 if it comes to that. If you don't want to use this, and I didn't get any pushback, so it ended up being in Kotlin. It's built on Spring Boot still. It uses a lot of the kind of characteristics of Spring Boot, a lot of the support for scheduling and task executing thread pools. We're not using coroutines at the moment, although I'm fascinated to experiment with it. One of the reasons for that is that we rely on the telemetry exposed from thread pool task executors. We have automated telemetry that hooks into those, that decorates the string beans. And we have some nice graphing that shows us when our system is under heavy load. And we would have to instrument the coroutine scheduler to give us that kind of same telemetry, and we haven't done that yet, or even looked at how hard it would be to do. But it's something I'd be really interested to follow up on at some point. So we're still using threads, effectively. But the really nice thing is that Orca runs pretty cold. It's pretty idle, because a lot of the time it's just waiting for some other service to do something. So I think we run 4 instances in production, but most of the time they're not very taxed in any way, whether that's I/O or CPU or memory. So to look at what it looks like in terms of, and remember this is just a single microservice within the Spinnaker system as a whole. We started out I pulled this data from the last commit before I merged the pull request that put the Kotlin-based queuing system in place. So that's like 65,000 lines of Groovy, and 13,000 lines of Java, and almost 200 lines of Scala, which we're using just for some load testing. There's a load testing framework that is based on Scala. And as of last week, The Groovy is what? The Groovy's actually up a little bit. The Java's up a little bit, but we also have like almost 16,000 lines of Kotlin in there. However, that's across production code and test code. If you look at just production code, there's significantly less Groovy and Kotlin. Interestingly, the Java figure is exactly the same. We haven't got a single piece of test code written in Java. Everything is production for Java. So we're taking an approach of kind of gradually replacing Groovy with Java 8 in some places. We made a decision to, we have a pretty typical multi-module Gradle project, and we kind of set a language maximum within each module. So there's a module that is 100%, a couple of modules that are 100% Kotlin that are at the very core of this queuing system and all the workflow stuff. And then there are a whole bunch of existing modules that were defining the stages and tasks that interact with the various other microservices in Spinnaker. And they didn't need to change. And they're mostly still written in Java and Groovy. But what we haven't done at the moment is combine Kotlin and Groovy in production code in the same module. It kind of seems like a sane line to draw, I guess. So I've got about almost 10 minutes left, so I want to talk a bit about testing. So we've traditionally used Spock a lot, and just to plug again, I wrote a book on it that you can buy, and then I can make a few royalty checks. But we started using Spec as when we were developing the queuing system for Orca, alongside of Hamcrest and Makito. So that kind of adds up to the, am I losing audio? Can you hear me? There we go. Those three things together are kind of the core of what we're using for testing most of Orca. Structurally, Spec feels pretty familiar to me because I'd done a lot of Jasmine when I used to do a lot of front-end code in a couple of previous jobs. So that kind of hierarchical structure, very R-Spec-like, was pretty familiar to me. Some other people on the team have found it a bit of an adjustment, particularly understanding just how the lifecycle operates. It's not as intuitive as thinking about just methods that are going to get run in JUnit or Spock test. Another limitation I found is it's really hard to use for integration tests. So we have some integration tests that use Spring's test support, so injecting beans into classes under test, for example, and running them in a cut-down container. And Spec doesn't really expose any hook points for that kind of thing, so we wrote those tests in JUnit using Kotlin. Also, implementation tests, if you're familiar with that idea where you've kind of got an interface with multiple different implementations and you want to run the same set of tests against all of them. We have, as I said, the queue is Redis-backed, but we also have an in-memory implementation of it for testing purposes, basically, and we have one that's based on Amazon's SQS, which we use. Really, we wanted to just prove that we weren't tying ourselves too tightly to anything Redis-based conceptually. And obviously, we wanted to run the same set of tests against all of those, and Spec doesn't have really any way to do that. It's super easy to do in Spock or JUnit, but Spec has something called subject spec as an extension, which you would think would be for doing that kind of thing, but it's actually really hard to define a subject that has any dependencies defined by the root set of tests. So we're still kind of up in the air on what we're going to do testing-wise going forward. There is a lot of enthusiasm for continuing to use Spock, even if we're writing production code in Kotlin, and I think that's pretty reasonable and realistic. One of the things I really like about Spock is it's opinionated about assertions and mocks. It kind of bundles all that stuff along. You don't have to think about what assertion library you're going to bring in and what mocking library you're going to bring in. It just says, OK, that's all bundled. It's one dependency. Away you go. So I have this kind of dream of one day there'll be something like that for Kotlin. That maybe I'll end up having a stab at writing sometime next year, but we'll see. So thinking about the future of Kotlin within our team and within Netflix as a whole, we are currently working on another service for Spinnaker, which is to do declarative continuous delivery. So this is the idea of you'll have some kind of YAML file checked into your source code repository that defines your cloud footprint and how you want to go about deploying things if we detect a delta between what actually exists in the cloud and what's declared in this file. So we'll run a pipeline based on discovering that delta, and we'll be able to do canary testing on that. So we're writing another microservice that will do all this, and that's going to be 100% written in Kotlin. So the team's quite enthusiastic about the idea. I know, obviously the engineering tools team as a whole, the guys who are working on Nebula and all these other services internally are pretty keen on Kotlin, and we've seen some interest from the team who are responsible for Titus, which is Netflix's internal container cloud, which should be getting open sourced at some point, and our encoding team who do some amazing stuff with using Slack capacity in our reserved instances on Amazon to encode all of the movies and TV shows. They're exploring some Kotlin for some stuff. I don't know exactly what they're using it for, but there's certainly some interest there. We've talked about the possibility in our team of having some kind of tool for turning Groovy code into Kotlin code. And I kind of feel like a lot of the idioms are so similar, you could probably get 80% of the way there with some automation and leave some commented out blocks that you would have to fix up later. That's something we might have a try at writing at some point, but that remains to be seen how practical it really is. But yeah, I think the future looks pretty bright for Kotlin at the moment, so I would expect that Kotlin in that word graph that I showed you earlier to get bigger over time. But again, nobody's going to force anyone to use it, so the nice thing is it stands or falls on its merits within Netflix. Nobody's going to make anyone use it if they don't want to use it. So people will come to it if it proves to be compelling, which I think it is. So with that, I think I'm about done. So thank you very much for your time. If you want to know anything about Nebula, there are some links there, or Spinnaker. There's a couple of links there. And we are hiring as well. So go have a look on jobs.netflix.com if you would like to work with some Kotlin at Netflix. And I have stickers. Come grab some. Otherwise, thank you very much.